Hello numbers here. Today we're going to learn an important theorem in mathematics. It's called the fundamental theorem of arithmetic. It's a very important theorem, as I said. It states that any integer greater than 1 can be written as a product of prime numbers. Okay, and it's unique for an integer. I've written prime numbers. I'm sorry about that. Now let n be that integer, and n is equal to, you can write n as product of primes like p raised to a into q raised to b into etc. z raised to k, where p, q, etc. z are prime numbers and a, b, etc. k as positive integers. Let's look at a couple of examples for that. And how can you write 60 as a product of prime numbers? Well, you first divide that number by the least possible prime number. You can divide 60 by 2. 2 is the first prime number. And when you divide it by 2, you get 30. And you can divide 30 by 2. Well, you can divide 30 by 3 as well, but you take the least possible prime number that can divide that number. So it's 2 again. And it gives you 15, which you have to divide by 3 because you can't divide it by 2. You can divide it by 5, but you choose 3 because the least possible is 3. So 15 by 3, that gives us 5, and you can divide it by 5. So that is a way you write 60 as a product of prime numbers. 2 times 2 times 3 times 5, or 2 square into 3 into 5. Now the next example, let's take a random number 637, and you can divide it by 7. Okay, what you're going to get is 91. Okay, and you can divide 91 by 7 again. Okay, 7 into 13 is 91. So now you get 13, and 13 is a prime itself, so you can divide it by 13. So the way you write 637 as a product of primes is 7 times 7 times 13, or 7 square into 13. Let's write n equal to p raised to a into q raised to b into etc. z raised to k, where p, q, etc. z are prime numbers and a, b, etc. k are positive integers. Alright, and what we are finding here is a number of factors, number of positive integer factors of n. And it can be found out by a formula that I'm going to write here. It's a plus 1 into b plus 1 into etc. into k plus 1. A, b, k, you know, they're the powers of primes in that product. All you have to do is add 1 to the power and then multiply. That is a plus 1 into b plus 1 into etc. into k plus 1. Now let's do an example right here. What's the number we're going to pick right now? Let's find the number of factors of 48. And for that, you need to write 48. We need to write 48 as a product of primes. Let's do that. Let's factorize it. Okay. Now factorizing it, the least possible prime number that can divide 48 is 2. So you divide it by 2, you get 24. You can divide it again by 2. That gives you 12. Then divide again by 2, that's 6. Again by 2, that gives you 3. And 3 can be divided by 3. So how are you going to write 48 as product of primes? It's 2 raised to 4 into 3. Yeah, you know it, it's 16 into 3. So the number of factors, positive integer factors of 48 will be 1 plus 4. That's the power of 2. And then the power of 3 is 1. So 1 plus 4 into 1 plus 1, that is 5 times 2, which is equal to 10. And we also know the factors of 48, they are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. There are 10 factors, and there we have it. Let's try one more question before concluding the video. The question is, what is the number of positive integer factors, positive integers, which divide 240? Okay, the same sense. Option A, 24, B, 20, C, 18, and D, 30. So as we have done earlier, let's factorize 240, and the first prime number will be 2, and then that gives you 120, which can again be divided by 2. That gives you 60, then 30, and then 50. So you have to write 4 2's, right? Yeah, 4 2's. And the 15, you can write it as 3 into 5 as product of primes. So 240 is equal to 2 raised to 4 into 3 into 5. Okay, so the number of factors of 240 is the power of 2 in that product is 4. So it's 4 plus 1 into the power of 3 and 5 are 1 each. So 5 into 2 into 2. That's going to be the number of positive integer factors of 240. That is 20. So our answer is option B, 20. Learned an important theorem in mathematics is a fundamental theorem of arithmetic, and using that we have a formula now to know the number of positive integer factors of any integer that you get. So thank you, and I will be back with another good video. Be safe.